Okay, so today we'll be continuing on seeing different modeling methods, and then I'll be giving you an in-class exercise that you'll be modeling, and actually that will be something like, let me find that. Okay, that will be modeling of this lamp. This will be the reference image that you have, and you'll be creating a 3D model that is as close to this as possible. So I'll be showing you some different form creation techniques. Last week we have seen, like last and previous weeks, we have seen some modeling methods. For example, modifying a box modeling, and using generators such as Lath object. And now I'll be showing you some other methods that, for example, we'll be using splines, and extruding them. And then I'll be showing you these modifiers menu, some items from here, which will be used to modify some primitives or other objects that you have. It can be a mesh or a primitive, a parametric object. So they are powerful tools that will allow you to create geometries based on different parameters. So let's start with seeing these deformers menu here. So that is a different type of item in Cinema 4D that is also located in here in the create menu under deformers. Okay, all of these are located also in here. So let me check this also. Okay, these are the effectors. We'll be seeing them later. So for example, let's start with a cube. And let's start, let's see what operators that we have. Okay. So let's see a bulge or taper, let's say, a taper operator. Okay, as soon as I add that, you see that there is an orange box with arrows pointing inside. By the way, the version that I'm using is R25, Cinema 4D R25 for this. Because because of the licensing issues, I guess temporarily I need to switch back to this. So if your interface or items have some differences, please note that that can be because of this. Please let me know if you can't see something or something is not in your screen. Okay, so as soon as I add this, this item appears here, and an arrow box is located there. Okay, so and the parameters or the options of that taper object is strength and curvature. So when I play with that, you see that this is moving, something is happening to that box, but nothing is happening to our box. Why? Because these deformers, these blue violetish colored items here, need to be a child of an object. For example, I want this cube to be tapered. So why that is happening, I don't know. Okay, so okay, I want this cube to be tapered. So I go and drag this taper inside that cube. Okay, so now this relationship here specifies that this taper is affecting this cube. Okay, so if I go to this taper and change the strength of it, you can see that now it is distorting tapering my cube's form, right? So There is also another option called curvature, but that is not working. Although I increase this curvature here, it seems to be not affecting the cube. Do you have any idea on what might be the cause for that? I'm changing this, but it doesn't affect the cube. Any idea? Yeah?
We don't have enough vertices.
Yes, exactly. So if I go to the hidden line mode, like display or grout shading lines mode, you can see that this cube that does not have any segments or divisions in this direction. So if I go to the cube and increase the segments here in Y direction, so see what happens. If I increase this, when I start to increase this segment number, that cube starts to conform to the outer taper deformer's curvature, right? So now if I go to the taper and play with the curve, now it conforms to my curvature, right? Yeah.
Taper'ın anchor pointlerini şeyleri de yanıp değiştirebiliyor muyuz? Taper hep küp mü oluyor?
Yeah, taper deformer, the overall shape is a cube. For example, I can add this to a sphere, for example. I'll disable the cube by clicking this arrow icon here. So maybe I can copy this taper by control or command click and dragging to that sphere. Okay, so I created a copy. So you can hit Ctrl C and Ctrl V and paste that taper and drag that inside the sphere, and that might also work. No. So again, you can see that this taper is defined by this cube. If you look at this here, Naz, it's still a cube, but it affects that sphere. And also notice that there's a sphere, but this taper deformer is larger than this sphere, so that can cause some problems. So it is most of the time it's best to have the same size of deformer with the geometry that you're working on. So if I select taper and move this, notice how this orange volume there is affecting that. Okay? So you can use this volume to selectively deform the geometry. So how do I adjust the size of the cube to the sphere according to the sphere? Either I go to the size and change parameters from here, but that's the hard part. Instead, you can go here and hit fit to parent, and it automatically snaps to the dimensions of the parent object that this deformer is attached to. Okay, so if I go to sphere and maybe increase the segments, you can see how more defined the geometry becomes. And I go to the taper and again, I don't know, play with strength and that kind of stuff. So you can see that how it is easy to create a water droplet-like shape with this method, right? So you can of course define the definition of the smoothness of your sphere or the water droplet, maybe. Okay. So yeah, this is one kind of a deformer. So I'll disable all of them. By the way, for example, if you want to do multiple enabling, disabling operations, you can click and drag and disable all of them, or enable all of them by clicking and dragging on that necessary part. Okay. Also, there is another option to show and hide objects in your viewport. That is these two little circles here. For example, if you click here, it's by default it turns to green. So it means that no matter what happens, it will be shown. But if you click again, if you click again and it becomes red, it means it is hiding that on the viewport. Okay. So they are hidden. They are still operational because these check marks are not crosses but checks. So they are still operational, but they are hidden. Okay. Sorry. Yeah. So let's try other operators maybe. I delete the taper deformer and then pass on to the bend deformer. Okay. So I can drag that bend deformer to the cube, and after that I can play with the strength, right? So but if you look at this, this is the front viewport. So when I do this operation, notice how the bottom of the cube starts to move upwards. Like, I don't want that because it's not so controllable in that sense. Or for example, I want to rotate it 360 degrees, but although the box completes a 360 rotation, the cube does not complete that. So do you see the problem? Or yeah, if you have questions, please ask, because like later on it becomes harder to understand. Okay, so when I start to rotate this, maybe if I close this, it can be seen better. Okay, so if I rotate this, notice how the cube is still moving upwards, but I don't want that. So this fit to parent is for that. For example, if I hit fit to parent, now that volume that bends this or deforms this cube is exactly the same size of the cube there. So if I increase the strength now, and you can see that the cube is completely rotating without any empty parts. So let's undo that. So when this gizmo was bigger, even though the rotation was 360 degrees, there were some empty space left. But if I hit fit to parent, then it exactly matches to the dimensions of that cube. So it becomes a more precision deformation, right? So of course these can be used to animate things procedurally, or you can like develop a model and use it like that. So this angle is something like that. You can make this dance maybe, I don't know. So yeah, this is the bend deformer. And of course, like this is the standard application of that bend deformer to a cube. So for example, let's make a joint, like 90 degrees joint. So you can connect two flat areas to each other by this jointed model, maybe, I don't know. Or maybe you can add fillet to that, increase fillet radius like that. So you can use different methods in combination with each other, okay? So yeah, this was the bend deformer. And let's see the twist deformer, which is another one, or maybe apply this bend deformer to a tube, maybe. I'll drag that to the tube and delete that cube. And now since the tube has a different dimension, this band deformer is again left bigger than that. So I go to the band deformer and hit fit to parent, and now it adjusts that accordingly. Okay. So if I increase the tube radius, or maybe height, let's say, and maybe increase height segments like this, notice that how it can be used to design or selectively bend that part of that cube. Or so the beautiful part of these deformers are they are completely interactive. So even though if you do something, it is easy to go back and forth between different options. So let's make it 180 degrees. So it's a completely different thing. Okay. So let's try another one. Let's say, let's delete this and add a twist deformer. By the way, notice that if I add this deformer and then put this inside that object, I always need to hit fit to parent because it doesn't know which object it will be attached to. So, but instead of that, if you select that object and before hitting this, if you hold Shift key in your keyboard and click this deformer, it is automatically created as a child of that selected object, and also its dimensions are adjusted to the parent object. So this is a very easy shortcut. If you select the object that you want to add the deformer to, and then hold Shift and add the deformer, then everything is done automatically. So now I'll play with the twist deformer. So since I'm seeing this in lines mode, you can see that some twisting is occurring. But if you go to the grout shading mode, you'll see nothing will happening, almost. So to see that, I'll decrease the rotation segments so that it can become like a screw-like thing, or sorry, 6, let's say. And now I can increase the rotation, and I can create a screw-like design maybe, right? So the annoying thing about this deformers is if you use that to create a complex geometry, these are obstructing your view, so you can disable the rendering of that in the viewport by double-clicking this circle here, so that it becomes invisible in your viewport, but it's still operational. Okay. So let's decrease that a little. This is too much, maybe. Yeah. So yes, this is another deformer. So let's see another one. For example, let's say a spline or a spline wrap tool deformer. So a spline wrap deformer is a very important one. And as soon as I do that, for example, if I go and put this inside the tube, nothing seems to be happening, right? And even though the strength is at 100%. So spline wrap, the object properties has two empty boxes here, the spline and the rail. So it needs a spline to operate. So for that, I'll be creating a helix, let's say. Okay. And change the helix direction to upwards like this. and maybe height to something like this. Okay, so then I'll go to the spline wrap and define that helix and drag and drop that helix to the spline part and destroy everything, as you see. So why this is happening is you'll understand in a second. Because there's an option, let's say, okay, there's an option called axes here, okay? It defines in which direction this geometry will be wrapped around along the spline. So if I change this axis to X, Y, and Z, let's try them first. So Y, okay, in Y direction, it's directly operational. So if you use some deformers and have some ugly geometry like this, search for axes or plane directions, okay? So try different parameters to understand what is not working and what is working. So do you understand what's happening here?
Hocam tekrar açıklar mısınız?
Okay, spline wrap.
Helix'e ekledim, ondan sonra ne yapacağım kaçırdım.
Okay, you add the helix to the spline here, and then you should be seeing your geometry deformed, right? Is it correct or is it in the, okay, it's destroyed. So to see that, to check for a solution, you need to check this axis property of that spline wrap deformer. So it's never a standard value because it depends on the orientation of your geometry in 3D space. If you create the geometry and a spline is in the other direction, it works differently, and if you do otherwise, it works differently. Okay? So has everyone done that and have seen some deformation going on? So the beautiful part of this setup is that it's completely interactive. So if you change the properties of the helix, it completely adapts to your changes, okay? And also this, of course, tubes changes. It can be a pipe or a triangular shape or something like that. Also, you can combine this with a twist modifier. So let's add that twist. And now I'm both twisting this and bending this, right? Whoops. But notice that the difference between, if you change the order, for example, if the spline wrap is first and then it's twist, it seems to be not working. So the order of these operations are also important. So for example, think this as, for example, this is the first operation, which means it twists this tube first, okay? You twist this tube and then spline wrap it onto this helix, okay? So the order of these deformers are important. So yeah, let's see another one, which is I'll group these, okay, under null. And if I double click this one, it will hide that null and all the underneath deformers, let's say. Okay. And now I'll create another thing. I'll create a cube and add a correction deformer, okay? So, and sorry, let's create that by holding the shift key. Okay. And if I create the correction deformer and go to the points mode, you can see that although it is a cube, which is a parametric cube, you can see that I can modify that cube through this correction modifier here. So the beautiful part of this is it is still parametric. So if I disable this correction modifier and enable that by clicking this, it returns back and forth between the original cube and the modified cube. Okay? So if I change the dimensions of the cube, you see that it is still operational, that correction modifier. So it stores the information that you've changed here as a parameter, and although this object is not transformed into an editable mesh, you can use this to create or deform geometry. So I can maybe increase some corners here and then go to here and click update, and you'll see that now it is it allows you to select some meshes and do operations around that. Maybe, for example, let's see if I can delete some. Okay, when I delete some things happen. Okay, maybe I can update. No. Okay, don't rely on this too much, but it can be used to distort the geometry mesh. Okay, so this is another type of deformer that can help you in the process. Okay, maybe I can add this correction deformer into a sphere and buradan a correction deformer. Let's hold shift and click that so that it is created as the exact dimension of that. So now this sphere is still a sphere, right? So it is still parametric. It's not made editable. But this correction deformer is doing polygon-based corrections or modifications on that surface. Okay. So yeah, generally I'd recommend don't use that because it can cause some problems in your process, but that's another way of modifying parametric geometry. Okay. So
Hocam bir şey diyeceğim, tekrar gösterir misin? Ben bunu yapayım. O seçemem.
if you add this, if you add this correction deformer, or let's see mesh, what's, okay, this is another thing. So if you add this correction deformer, you should go to either point, edge, or polygon mode to be able to select these surfaces or polygons, okay? You were asking that, right? Okay. So on top of that, by the way, I can add this subdivision surface and put this inside, and you can see that now everything can be smoothed out so that I can create kind of interesting geometry. I don't know what this is, but or maybe it can be a stool. So you can always reset your deformations by going to correction and hit reset. So I'll just try to make this a 3-legged stool maybe by selecting these. I don't know why it's not selecting, but let's see. I'll disable this. Okay, it doesn't allow me to select while this subdivision is active. So, okay, select this two, select this two, and select this two, and I can move them downwards like this, and then enable this subdivision surface. So maybe it can be a tooth. I don't know. And maybe scale them like this. And scale them like this. Okay, so it can be something like a stool design. I don't know. So I can go again to the top part and select some polygons here, and maybe these, and scale them down like this, make it flat, and move them down like this. Yeah, and like I can make a smooth stool like this. Okay, you can combine different methods with each other to keep things still parametric, and which will allow you to do further adjustments on the go.
Hocam ben şeyi bulamadım. Correction'ın altında deformers yazıyor ya. Onun nereden ekledin?
Correct. Ha o şey, o these are different things. I've hidden them.
Ha.
They are not relevant to the scene. Okay. So, as I mentioned in the beginning, we can also use curves to generate 3D geometry. Okay. So, okay. By the way, there are many other deformers here that allow you to do different things. Okay, you can explore it on your own time, or we can play with them later. Huh?
Bunlar animasyon için mi?
Deformerlar mı?
Yani bazıları sadece animasyonla mı çalışıyor?
Yok.
Mesela şey falan, explosion falan, jiggle falan.
Jiggle, for example, yeah, maybe for example, let's see jiggle and add a jiggle deformer there. So, okay, I need to, I guess, increase segments. Okay, jiggle is kind of a physics simulation, and yeah, you're right. It kind of works on simulations. So, for example, okay, I need to show you that. I'll add. This is the physics simulation that I'll be creating. So I'm creating a plane. We can see this later on, but I'm showing you only for the demonstration purposes. Okay. So Cinema 4D also has a different system called tags, and I'm mentioning that this disk is a collider. So it's a static object, and it will collide with objects. So, and I go to the cube and add a tag, and that's a rigid body. So, which means it will fall down, it will crash, and that kind of stuff. So when I hit play, sorry. So when I hit play, it falls down, okay, and collides with this. So if the disk is rotated, let's say, it falls down, okay? So if the cube has a jiggle deformer, probably it will be something like jelly. So let's see. Yeah, okay. The strength, let's say. Ah, okay. The cube, no. Let's see. Okay, strange things are happening. Maybe it can be added to a sphere. So yeah, it's kind of a deformer for simulations. Yeah, you're kind of right. Okay, so
Bizlerse hiç simülasyon veya animasyon şeylerine girecek miyiz yoksa sadece modelleme mi olacak?
ya modelleme odaklı ama isterseniz gösterebilirim. So yeah, let's continue on creating different geometries. So and as I said, like there are different deformers here, and also maybe I can show you another cool one, which is displacer. So if you add a displacer onto an object, and if you go to the shading tab and add a noise there, you'll see that you'll be able to distort the geometry of a form by using noise algorithms, okay? So what is beautiful about this is you can use different noise types and create different geometries. And what is more beautiful is that you can animate that, okay? And different noise algorithms behave very differently under different conditions. So, okay. This is still a deformer, but it's deforming the geometry based on an image, a noise image. Okay. So yeah, this is another kind of deformer. We can explore this further when you need and if you need. Okay. And let's see, before the break, let's see other generation types, which are called for generator types, let's say. For example, loft. One is the loft. Another one is sweep. Last week we have seen lathe, which we used to create vase-like forms. Okay. And yeah, loft and sweep. So sweep is kind of similar to the deformer that we've seen, spline deformer. But let's start with the sweep. And I'm creating a box and putting that inside that sweep. Because it's a green object, it needs children underneath. Okay? And sweep object needs two objects underneath. One is for the shape, which will be swept. And the other one is the let's say the path that this shape will be swept along. So that will be the second child. So the first child is the shape and the second child is the form. So maybe instead of arc, let's go to the right view and maybe create a spline. By the way, if you use, there will be doodle paint, okay? This, no, not this one. Okay, if you click and hold on the spline pen tool, there is a sketch tool, right? So if you use that, you can drag your mouse and sketch something. Okay? And yeah, okay. You can smooth your sketch by increasing this property. And now if you use that as the second object in your sweep, you'll see that that sketch that you've done has become 3D with a profile of this first shape there, okay? So I can change this property. So I can sketch a chair form maybe. Yeah.
Bunun spline wrap'ten farklı olması şey mi? Spline wrap mevcut objeyi şekle sokuyor. Bu objeyi kopyalıyor mu uçucu?
This generates the object. That the other one is deforms the object. So let's see this. Okay, let's see the difference. I'm hiding this. And we have this spline wrap tool. This spline wrap tool, of course, has different properties than the sweep tool. Okay. Actually, they are kind of similar, but what this spline wrap tool deformer does is like it deforms a tube based on this helix, right? So I need a curve, and I can play with the definitions of that curve. And this sweep object generates this based on only splines, but this deformer uses 3D geometry to deform. Actually, it depends on the application. Sometimes spline wrap might be more beneficial for your process. Sometimes this sweep can be more beneficial. Okay. No, thanks for asking that, because that's an important thing. So this sweep tool has some different properties, like for example parallel movement, keep let's see, display, sure, banking, and these options become handy. For example, you can also adjust twist along the path, or you can use these to drive an animation, for example. You can, of course, like caps can be open, the top and bottom part can be open or closed. You can adjust that. Also, of course, you can bevel the shape like this. You are more in control of this shape while doing this, maybe, let's say. Also, the spline here, I can adjust and play with the properties of that spline. Let's see, okay. For example, I can use and change the position of these curves to modify my form, always, okay. And of course, I can, instead of a rectangle, I can use a flower, for example, and use it as the first object. I've destroyed it because it has 3 objects, but if I delete this rectangle here, now you'll see that it has become, okay, so there is a problem here because of the orientation of this flower probably. So I go to this flower and change the plane. You see, when I change the plane, it's fixed. Okay. And of course, like the second object doesn't have to be a spline like or a freeform spline. It can be, let's say, again, a helix, a formula, or whatever you like. So I'll put formula in here and delete the spline. And you see, it is kind of broken because this formula here is too small. I select that and scale it up and nothing happens, okay. So let's see. Okay, because I need to change the parameters of that. So let's make it to maybe, okay, formula is not the most suitable one here. So let's say make it a star put this inside here, and I can make the star bigger and enable this sweep, okay, and increase the star again like this, and you see a different kind of geometry here. So the beautiful part is, again, I can always play with these parameters. I can change the petal number, for example. If I increase the petals too much, it becomes something like a very complex form, right? Stair-stepped thing, maybe, I don't know. And also, if I go to the star and again add bevel or something like that, oh, I can twist that star. Okay. And change the number of stars. So yeah, it's all playful. I think don't be afraid to play with parameters, but always keep in mind that it is always to play with a single parameter at once. Don't change all the parameters without understanding, okay? So understand which parameter is doing what. So again, in the sweep, I can go and play with, let's say, end scale. So I can animate this, I don't know. So notice what these parameters are doing and that kind of stuff. And in this details tab in the sweep, I can use curves to play with the scaling or rotation. Okay. So there are many properties that there are to play with. And don't be afraid to play with different parameters, but don't try to mess up with many parameters at once. Okay? So yeah, this is the sweep, and let's see the deform part. And we'll be seeing that in a moment. So Loft again works with curves, and it creates geometry out of the combination of the curves. For example, I'm creating this rectangle, and I'll select the move tool, and I'll create a copy of this and hit command and drag this, command or control, and create another copy. See, there's rectangle 1. I'll do that again, hit command or control and drag this. Okay, it created another copy. And now I'll scale this, the bottom one. For example, let's do this like that. Okay, and put all these curves into that loft generator. So immediately that created a flowing surface or a form between these 3 different rectangles. So I'll see this. Oh, I made a coffin. So, and again, if I increase the dimensions of this or decrease the dimensions of this, you can always create different sets of geometry. Okay, and the beautiful part is, like, of course you can move this upwards or even rotate that, but notice that something bad is happening there. That shouldn't be. These polygons shouldn't be crossing or intersecting with each other. That can cause many problems in your workflow. Okay, keep in mind that. So yeah, I can use this to create this kind of a form. And of course, I don't have to include everything as rectangles. So, or maybe I can change the parameters. I can round that middle rectangle like this. Okay. So it becomes smoother. And yeah, there are different properties here. And you can subdivide that while in the loft properties there. Okay. And let's round these. Okay. Of course, for example, instead of rectangles, I can use n side like this. I can copy this, this, and this, and create, for example, one can be an hexagon. The beginning can be a triangle. The second one can be a hexagon. Again, a triangle. And it can be finished with a hexagon. Okay, so let's increase the size of the triangle there. So notice how this form is transforming from a hexagon and turns to a triangle, and again transforms back into a hexagon there and finishes as a triangle. So this loft generator creates a transitionary surface between different geometries or different curves that you generate. Okay, so this is a very powerful tool actually. And also, for example, there should be caps. Caps parameter of the loft means these ending points, so you can smooth them out but by creating a bevel. And if you select step, you can create something like a stepped effect like that. Okay. Yeah, so this can be a very experimental skyscraper maybe. So let's try. I don't know. Okay. So let's move this backwards. And again, the beautiful part is if I select this and rotate that, it will be twisting around that axis. So I can copy this upwards, but it puts it at the top. So, okay, I can move this up and put this here and rotate this in that manner. You can combine or deform the geometry as you like, okay, by using the ordering of these, but this is going from bottom to up, okay, so I'm going down and the order is one after another, so it's flowing through the surface. The ordering is important in the loft object. Okay, so let's take a break, and until now, do you have any questions or comments about the tools that we've seen? Okay, so after the break, I'll be showing you how you can model this lighting design lamp here. Of course, like there are different ways of doing that. I'll be showing one or two or three, I don't know. I'll be doing that on the go. So, and yeah, then on the third hour, you'll be doing this by your own and uploading as a class exercise. Okay?
Kaçta gideceksiniz?
4.